Awesome. Well, this is quite a few people. Welcome everybody. My name's Tate. I'm a co-founder of Nest.land, and I'm here to, host the first Dino/Nest.land Hacktoberfest event. Here with Michael Spengler from SAP, Sam Williams from Arweave, and Ryan Dahl from Dino. I have a quick presentation to give really quick, or I already said that. Quick presentation, and then and then we can kick off to the presenters. Awesome. Sam or anyone, can you see this?
Yep, you can see.
Perfect. Okay, so not too sure how many of you know about Nest.land already, but I'll give a little bit of info about Nest.land in advance. So Nest.land is a module registry for Dino powered by Arweave. And luckily, you'll be able to hear about Dino and Arweave following this presentation. But yeah, so basically we host modules on the PermaWeb and serve them for any Dino developers. And that's how we work. So this Hacktoberfest event is focused on building modules and collaborating with others over the weekend right now as well. And right after this event, we'll be accepting pull requests to our registry where you can log your contributions, and you can also log the modules that you've built. So you can access more information about this on hack.nest.land, and you can also find the repository there. And special thanks to SAP, the tools team, Dinoland, and Arweave. And right here to the right, we got some socks in the works so that people building modules can receive some Nest.land socks and potentially other kinds. But I'll be able to go into more depth in the coming days. And also we got some laptop stickers, so we'll be distributing those to people that participate as well. So yeah, super excited about that. Another thing that we're really we're rolling this out, trying to seed our community, is this concept of profit sharing tokens. And Sam will go into much more detail about this. But essentially we're using profit sharing tokens to reward module developers for the for the value that they add to the ecosystem. And we'll also be giving them to Nest.land codebase contributors, and they can also be used for platform governance. So anybody that participates in this event will also be rewarded profit sharing tokens. So yeah, with that, let's transition to Ryan, who will give a presentation about Dino.
Hi.
Hi.
Let's see here. Share screen. Can you guys see my screen?
Yes. Awesome.
Cool. Hide this. Oops. Hello. Hi, everybody. I wanted to give just a quick talk, and this is going to be much more detailed and about kind of Dino internal stuff than you might have seen in some of my other talks. The idea being that I think the people gathered here are probably familiar with Dino already, and yeah, maybe just talk about a bit what's on my mind in terms of development these days. Yeah. So right, as I said, there's a technical talk, and it's directed basically at the people directly involved with Dino. And for those of you who are not directly involved, maybe I'll just give you a sense of kind of where our priorities are at. But yeah, if you don't know what Dino is at all, I really apologize. I've misjudged misjudged you as an audience member, so I apologize for that. But there's other talks. I've given tons of talks on Dino, and you can go find out about that. But yeah, this is going to, if you don't know what Dino is, immediately be incomprehensible. So with that said, by the way, can you guys hear me?
Yes,
we can
hear you.
Yep.
Awesome, thanks. Just don't know if I'm speaking. My fear about giving these talks at home is that I'm like continuing on and everybody else can't hear anything.
Yeah, it's super disconcerting. That actually happened to me a few weeks ago. But yeah, we can hear you.
Great. I'm glad I can hear you too. Okay, cool. Yeah. Anyway, so Dino as the Dino CLI, as we call it, is probably what you know to be Dino. It's this program that runs in your terminal. We call this the Dino CLI. This is actually just I wouldn't say it's the tip of the iceberg, but it's just one component in kind of a larger ecosystem of systems. I've built Dino, organized Dino this way in part because of the experience we had with Node, where we realized that there's different applications for applying a JavaScript runtime that don't necessarily involve interacting with it on the command line. You can imagine different situations. For example, maybe you have a database and you want to write MapReduce functions in JavaScript. In that sort of situation, you don't really want to have access to the file system, say. So the Dino CLI is really a system for interacting with command line scripts. You know, there's functionalities for interacting with the operating system. But that's built on top of a thing called Dino Core, or just Core. And this is a Rust crate which provides ops and resources. Ops are essentially Dino's version of system calls. It's ways to break out of making RPC calls out of the VM into Rust, into the Rust world, and you know, the larger operating system. And resources is essentially our version of file descriptors. They are in JavaScript. They're just integers, and there's a resource table, and they represent things that are allocated and managed in Rust that we want to reference in JavaScript. We can't actually provide like a 64-bit pointer to the resource. You know, not only is that kind of a security problem, but JavaScript can't handle 64-bit pointers, 64-bit integers, whatever. Anyway, so we have this Dino Core thing. Talk about that in a bit more detail. On top of Dino Core are op crates. There's currently 2 of them. These op crates are basically components of the Dino system. So they provide various JavaScript APIs. We have 2. This is a fairly recent development, and we only have 2 of them right now. We have Dino Web, which provides these things you see listed here: DOM exception, event target, event listener, A to B, BDA, text decoder, etc. Those are, yeah, kind of the base level, easy things to implement. Web APIs that are kind of easy to implement. And then there's Dino Fetch, which implements the fetch root call, and then all the objects kind of associated with it. Fetch is actually a fairly large API. It has request and response and all of this streaming stuff. So those 2 things sit directly on top of Core and don't actually depend on anything in the CLI. I'll get more into that. Below all of this is Rust v8, which is essentially one-to-one bindings of V8 C++ API into Rust. We try to keep to the C++ API as close as possible, but we also try to make it Rust-y, hence the name, and we try to make it safe to interact with in that kind of the type system encodes the correct way to interact with V8. V8 is massively complex. It's hard to describe how complicated V8 is. It's a crazy piece of machinery, and being able to interact with V8 in a safe way is pretty awesome in terms of being able to build a system like this robustly. There's also this whole build system integration. It's such a it's so painful that it gives me chills just thinking about it. V8 is part of Chrome. Chrome has its own build system. Chrome is massive, so massive, and is all written in C++. C++ essentially does not have a defined build system. Various people use CMake, make, whatever. There's various systems. Chrome has invented its own system. It's called GN. We interface with great care and with great pain, Cargo and GN, so that we are able to build V8 from source and link it into Rust. And yeah, I would just say this is a very non-trivial effort. It's, I would say, 2 years in the making or so. There have been multiple attempts at this that we threw away until we finally have settled on the current Rusty V8 framework, which I think is working quite well, actually, and we think that it will be around forever. So what's cool about Dino Core is that that TypeScript and Tokio is the event loop software that we use, the event loop Rust software. Both TypeScript and Tokio are not in Dino Core at all. So that makes Dino Core is not just a slimmed down version of the Dino CLI, but it's really removing massive amounts of complexity from the system and allowing us to really factor the problem of creating Dino into various subsystems. Yeah, it's just hard to express how complicated this system becomes. I mean, we were talking before talking with the others in the lounge before this about how Dino is kind of a web browser for the command line. That's true in its complexity as well. Providing these sort of APIs involves some pretty complex systems, and being able to manage this in a sane way is really important. So yeah, TypeScript is just a massive complexity that the Dino CLI has taken on, and I think that the users of Dino appreciate, because you're able to use TypeScript out of the box. But it's a huge load on us to make this work properly, and there's a lot of issues. So in particular, the CLI includes 3 distinct parsing infrastructures, which sounds insane, but it is justified. Obviously, V8 has to be able to parse JavaScript, right? It's a JavaScript runtime. But TSC, which we need to do type checking in TypeScript, that is the TypeScript compiler from Microsoft, also parses JavaScript, as it does TypeScript. It's very slow. Which is why we also use SWC, which is, TSC, by the way, is implemented in JavaScript. SWC is a JavaScript and TypeScript parser made by Kang, KD9, I forget what his username is, but Kang, awesome programmer. He's written a TypeScript parser in Rust. It's very fast, and we use this to strip out, that is, transform TypeScript into JavaScript. We also use it for doing static dependency analysis. We use it for formatting. We use it for linting. We use it for documentation generation. So basically, we don't want to really use TSC for these things because it's so slow. We would eventually like to have type checking done completely in Rust, but that is very non-trivial. Yeah, anyway, Dino core is not does not depend on all of this stuff. Only on V8. And similarly, which is kind of amazing. I don't know how into Rust you are, but the event loop. This is an asynchronous runtime Dino, and so the event loop is pretty like pretty critical to its operation. It's a core piece of infrastructure, and prior to this, we built this library called libuv, which is the basis of Node, and the idea that Node could somehow decouple itself from libuv is just laughable. It's very highly coupled into the system. But in Dino core, actually, it's not dependent on any one event loop, and this is actually due to the awesome design work that has been done in the Rust world around the future abstraction. They're actually able to represent asynchronous calls in kind of a platform independent way, so that the Rust futures don't actually depend on Tokyo. So this is really cool because we're able to kind of test. We're able to connect kind of the asynchronous nature of JavaScript, that is JavaScript promises, and Rust futures, and we're able to connect these things without actually involving any system calls or anything. And so we can kind of test this asynchronous system without actually doing I/O. And yeah, so I think what's cool with core is not visible to the broader community. It's just a piece of infrastructure, but it has been hardened over the last couple of years that we've been working on this. And indeed, the core part of Dino is essentially grown out of some code that I've been working on from like 2015 or so. So it's gone through these little bits of code that get rewritten and moved around and renamed at different points. It used to be called V8 Worker. It was like a Go thing. It's moved around over the last 2 years. It's been called Dino Core, and I think that's the name that will remain. But the system is fairly robust at this point. It's been hardened through years of bug fixes and refactors on this, and at this point, Dino's has kind of a growing community around it, and there's a lot of effort to make the CLI usable for people, and all of that kind of results in core being this hardened piece of infrastructure. And so that's why these days core and opcrates are being used in non-trivial, not yet released products from multiple companies. Like these are pretty serious pieces of infrastructure at this point, and we are investing more and more in them. That said, there are problems that still need to be resolved at this layer. And this is important because there are systems that sit on top of Dino core that are not the CLI, that I can't tell you what they are, but we need to make sure that the abstractions there are appropriate for all different users of the system. So over time, this op model, that is the RPC mechanism for calling out of V8 into the native world, out into the Rust/operating system world, has evolved. It started out as kind of a TCP stream-like abstraction where you could send and receive arbitrary buffers back and forth, array buffers actually. But these days, it's really solidified into something more of an RPC-like abstraction, essentially these promises. And we have found that we end up building, obviously Dino does implement TCP streams, but it's done on top of an RPC mechanism. So for example, if you're reading, you would have a resource that represents a TCP stream, and if you want to read from it, then you call the kind of you make a read op, to call. So anyway, it's kind of call and response. And kind of the lower layers of the Dino core still kind of reflect this earlier stream-like abstraction rather than kind of how we currently use it in this RPC fashion. The op model currently, because it's based on top of this kind of stream-like abstraction, creates promises in JavaScript and kind of creates identifiers for those, calls out into, encodes them into some buffer, sends it over to Rust, and Rust calls us back, and we resolve promises. This is all done in JavaScript at the moment, and it works. It's fine. But we think that kind of refactoring the system to be more RPC-like might be helpful, and that is essentially moving this promise table from JavaScript into Rust and actually creating promises in Rust. I think will be beneficial in the long run. We're having some problems with the kind of ownership of resources on the Rust side during async ops. So you can imagine if you're in Rust, you're in an async function that's implementing an async op. You may want to await various things on resources. So you might want to do socket.read.await. This is not possible because the ownership of the resource currently is sitting inside this resource table. And so when you pull it out to operate on it, you have kind of you're borrowing a resource, you're borrowing a reference to this resource, a mutable reference even. And this is a problem when you're kind of crossing await boundaries. So we kind of work around this issue by using pull.fn a lot. I'm sure this is going over many people's heads right now because you're not involved in this Rust stuff. Don't worry about it. But yeah, essentially we have some problems with the ownership of resources, and yeah, we're going to be working on that, and we think we have a tentative solution. And then there's another problem, which is that there's a couple of extra non-op bindings, that is bindings, actual JavaScript functions that are not ops, that are in Dino core. These are things like eval context, get promise details, get proxy details, and these are essentially things that we would like to be ops, but we want everything in Dino to go through this op mechanism so that we have a central place for all sorts of RPC. But these were various systems that we weren't able to fit into that model. And I think further refactors of Dino core, would hopefully answer the question of how we can make these things into ops themselves. The op crates, that is like the Dino fetch and the Dino web, things that are built on top of the Dino core have problems as well. So for example, the op crates are implemented in pure JavaScript, and they only depend on this Dino core. Again, Dino core doesn't depend on TypeScript, but this kind of provides some issues because obviously the CLI does do TypeScript stuff. So we have to provide a TypeScript declaration file, type declaration file for these various op crates and provide them to the CLI. Presumably, we want these things kind of co-located inside the op crate so that if we change the interface of one of the functions, we can also update the declaration file at the same time. But the op crate itself cannot actually call TypeScript, so it can't actually do any testing of these type declarations itself inside the op crate. And so there's kind of this I would call it an impedance mismatch of kind of this TypeScript system, and we're not quite sure how to make this work in a non ugly way. And speaking of ugly, kind of the Rust API that the op crates present is kind of ad hoc and not very uniform. In particular, each callers of people who are using systems that are using these op crates need to like register each op that the op crate provides manually. It's a bit hacky. And basically it's that way because we need it to work. And so what we'd like to do is kind of go back and kind of provide a unified system for all of these op crates to implement a uniform interface that they can all implement, so that it's very clear how to interface with these op crates. And in particular, this kind of brings up the question of plugins. Dino has a plugin system. Plugins, also called add-ons, extensions, DLLs, look very similar to op crates. They are crates. They have an init function. They often implement ops. They often have a bit of JavaScript. Very, very similar sort of functionality. The difference, of course, that plugins are basically loaded at runtime, whereas op crates are statically compiled into the binary. These are very similar sort of things. It's like a static lib versus a dynamic lib. We would like these interfaces to not just be similar, but actually exactly the same, and that you could actually take an op crate and compile it as a plugin that you loaded dynamically, or vice versa. You take a plugin and stick it into the build and stick it in as a Rust crate dependency, and then suddenly it's statically built into the final binary. And yeah, we only have this Dino Web and Dino Fetch op crates, which might tell you about who the potential users are of these things. But the question is, how can we extract more of the CLI into op crates? There's lots of other systems that don't implement these op crates. So for example, we have Dino.watchfs, right? This is not an op crate. This is just implemented in the CLI. Could very well be an op crate. But because of these kind of interface questions, we are not very eager to move huge chunks of the CLI into op crates, because we haven't quite worked out this interface yet. So yeah, that was a quick little talk about what's going on in the system, and hopefully I left a bit of time for questions or comments. Oh geez, looks like I've been talking for 25 minutes. I apologize. Are you guys still there?
Yes, thank you so much for that, Ryan. No problem whatsoever. If you want to talk more about this, maybe we could, maybe you could go to a table afterwards and chat with anybody who might be interested. And also, people can also go to the Dino Discord if they wanted to talk about this. Am I correct in saying that?
Yep, and I'm on there, and people are welcome to message me privately or in public.
Awesome. Thank you so much, Ryan. That was awesome. Cool. All right. So Sam, you're going to talk a little bit about Arweave and profit sharing communities. Is that correct?
Okay, cool. That is correct. Let me share my screen. So now it's my turn to be concerned that I'm... can you guys see this and also hear me at the same time?
Yes.
Optimal. Okay, good. I gave a talk a while ago, and that was not the case. I was talking to myself for a while. It's very awkward. Anyway, okay. Thank you for the kind of deep dive on Dino, Ryan. I'm going to take kind of like a, I guess, what did you say? Related but slightly disparate look at something that intersects with the ecosystem. So when Dino was first properly announced, we saw this blog post where Ryan was talking in very interesting detail about this idea that Dino can be a web browser for code. And this is really fascinating, and this kind of overlaps with some of the things we've been thinking about at Arweave, which I'll kind of get into in this talk, and we'll see how it sort of threads together and also butts up against profit sharing communities, which Tate's been talking about a little bit. So first of all, we have to start kind of from a different location. So just stick with me for a second. It'll make sense in the end, I hope. Right. First, what is Arweave? Arweave is a, let's get rid of this bar. Arweave is a permanent decentralized data storage system. So basically what it's doing is it's taking the blockchain-like structure of Bitcoin, making it so that you can fit very large amounts of data inside, and then also making it so that you can make that economically sustainable. Yeah, so those are the two kind of core innovations with this system. On the technical side, rather than the economic side, the main innovation is what we call succinct proofs of access. So a mechanism that replaces proof of work in Bitcoin, which is essentially guessing random numbers in order to produce blocks. I'm simplifying a little bit, but that's probably what's happening. In Arweave, proving that you have access to random pieces of a data set, and then making it so that people can add to that data set over time. And this essentially allows you to scale up the permanence and immutability of data storage, yes, to much that you would get on Bitcoin. So if you write a transaction into Bitcoin spread across tens of thousands of machines all over the world, it'll definitely survive, any kind of nuclear war or really actually almost any doomsday scenario. You get that kind of permanence of the data, but applied to much, much larger quantities of the data. But of course, that begs the question, well, how can you make that economically sustainable? So if you pay to store something once, where's the incentive for people to continue storing it over time? Like, surely that's not possible, you'd think. The way that we solve this problem is with the second innovation in the system, which is storage endowment. So we basically don't use the traditional, what we call contract-based storage model that you would get with AWS or something like this, or Dropbox, or really any other service actually at all. So there you would say, okay, I would like to store my file for this period of time, and that's going to cost me this amount of money. It's contract, right? With Arweave, you're doing something slightly different. You're saying, okay, I would like to contribute this piece of data. I would like to pay for it for a single time, and that fee will be used to set up an endowment. And that endowment will yield interest over time, and the interest is then used to pay for the storage of data. So this is kind of similar in principle to university endowments. So some typically well-off person says that they would like to make a large donation, say tens of millions of dollars, I don't know, $30 million, and every year that $30 million yields 300K or something in interest, and that $300,000 is used to pay for tuition fees for students. And you can do this indefinitely. The $30 million, which we call the principal, is never actually taken away. It's always kept, but you use the interest on that principal in order to pay for the thing. And just instead of it being university tuition, we're doing it with storage of data. And so that allows you to make a system that can perpetuate the data that you store inside it essentially indefinitely. We've tuned the Arweave network so that it's extremely conservative. It's expecting an interest rate approximately 1/31th of the actual interest rate that it gets in the real world over the last 50 years on average. So this is a very, very reliable archiving system for storing data. So this brings us to Dino. Dino is essentially a web browser for code, like this idea that you can have a piece of code that imports other code from a URL. This is incredible. It's so obvious and also so necessary. I don't know why we didn't do it before. This is a great thing, but the problem is that the web that this is relating to, or would you say accessing, is brittle and temporary. So you can have a single URL, and that URL over time can change what it is that it's pointing to. And this is a real problem if you're including it in your code, because of course now what you've done is created a dependency on the person that operates the server that you're accessing, not to change the code. Okay, interesting. This kind of relates to what we've been working on at Arweave. And as soon as we saw this blog post about about Dino in the first place, we were like, wow, wouldn't it be great if someone were to build an integration between Arweave and Dino so that you can make the code that people are accessing from the web permanent? And that's actually precisely what Tate did, just a few weeks later, in fact. So on top of the Arweave base layer, it's available in what we call the permaweb, which is really just all of the data inside the Arweave network made available through browsers and indeed at URLs. And so, of course, available inside Dino. In general, we're going for well, you could think of it like trying to build a new Library of Alexandria is the like ultimate goal. But of course, in the modern age, Library of Alexandria doesn't just have records of history that are buried deep inside what's called in the blockchain space proof of work. So something that's very hard for other computers to forge without expending value. So if there's, for example, information from protests in Hong Kong from a year or two ago, they are now buried under a huge amount of work that's been done, computation that's been done by computers. And so very hard to forge, to go back in time and to try and modify the records of. In fact, really, it's basically impossible at this point. And so now, if you say in decades time from now, if you were to look back at those original sources from the Hong Kong protests, and there's tens of thousands, if not hundreds of thousands of them on Arweave, you can tell verifiably that those sources have not changed over time. So this is pretty valuable, we think, and it's really flips the game relative to normal archives where everything is open to be manipulated during the process of storage. So we solved that problem completely, we think. And the same with knowledge. We want it to be a collection of knowledge that will just never go away. There's a huge number of links on Wikipedia, for example, that they're read, right? We all know them and we don't like them because it means that this assertion about something is now unsourced. You can't go to where that knowledge came from. Just for example, well, the permaweb solves this. If you store the knowledge inside the permaweb instead, it's just never going away. It's backed by this very, very robust economic endowment structure. It's decentralized and spread across tens of thousands of nodes all over the world, so that knowledge simply cannot be lost. But also, of course, a Library of Alexandria for the modern age should obviously include code. In fact, we kind of see code in applications really as what you might call knowledge for computers, right? So if knowledge is just in some kind of, at some level of analysis, it's really just instructions about how to do things in the world. So I know how a car works. Well, I don't know how a car works, but I know that some people know how a car works. And those people have the knowledge which allows them to do something in the world. Code is exactly the same. It's just like for computers. It's if you're familiar with Dawkins' idea of a meme, and not quite just the cat version, but this broader idea of a thinking tool. And it's precisely that. It's just a thinking tool for a computer. So how do I achieve a task? And then the human typically summons the knowledge on the computer, and it executes and it achieves a task function. But that's super abstract and philosophical. We don't need to go to that level. But the core idea is that just like the web, code should be accessible and permanent inside the system like everything else, but also applications should be able to run on it. So if you point your web browser at an Arweave transaction, and all data is stored inside what we call a transaction, but you can think of it just as an interaction with the system. If you point your web browser at an Arweave transaction ID, if that transaction is a HTML web page that perhaps contains CSS and JavaScript, or even Dino, it'll download and run it on your browser, just like any other application anywhere else on the web. And that allows you to build permanent decentralized applications. So obviously this is very handy for Dino, we think, and seems like with the pickup that Nest.land has seen, that some of the community at least agreed to. It would be nice if you could just reference code that had an immutable, permanent backing in this kind of shared knowledge space, and you just knew it wasn't going to change or disappear on you. And then you can I guess, code with a slightly higher level of confidence. So that's kind of like a brief idea of how the permaweb works and how it relates to Dino. And then Nest.land is the thing that sort of glues this stuff together. So you contribute your code to Nest.land. It's stored or backed on the Arweave in these decentralized endowment structures, make it economically sustainable to just perpetuate it forever. But there's a kind of broader vision that we're pursuing at Arweave as a community and a collective, which is to change the what would you say, ownership and control structures of the web. So we see at the moment that essentially the problem from which all other problems on the web, or almost all other problems on the web, stems is that everywhere on the web is owned by a corporation. And that corporation has a profit motive, which they are pursuing to attempt to extract value from you, the user. So it's as if like you wake up in the morning. I mean, to make a comparison between physical and cyberspace, it would be as if you wake up in the morning and you realize you're in a bed, and that bed is owned by a corporation which is attempting to extract value from you. You go out onto the street, you realize you're just accessing the property, in this case the service, of another corporation which is attempting to extract value from you. And this process simply doesn't stop. There is nowhere on the web that is not owned, apart from the permaweb. The idea here is that actually, once created, there is no real concept of ownership of a piece of code or of a piece of knowledge or anything like this, because nobody can assert any kind of control over it. It's completely immutable. The person that uploaded it has no more rights than anyone else in the way that that it is used or anything else in the future. There's just nothing you can do about it. You upload it, it's just there. So this is pretty interesting, and we think makes the foundation for ownerless cyberspace. Places in cyberspace that you can go that do not have companies controlling them. But on top of this, you can build pieces of code which then govern how sub areas of that cyberspace work. So for example, you could think about building a Reddit-like system where a decentralized community of people get to vote on how it's moderated. And this then becomes the governance mechanism for that area of this shared cyberspace. And what this looks like in practice is what we call profit-sharing communities. Profit-sharing communities are essentially an attempt and really like a series of experiments that the Arweave community is pursuing in building better governance models for web companies. Well, would-be web companies or web applications, in fact. So they work in a few different ways simultaneously. First, we looked at the process of value accrual and profit sharing in the Web 2 world. And we realized that basically, to put it in as polite terms as I can, it's very hard to understand where the value behind a Facebook stock, Facebook common stock that you could buy actually comes from. And the reason for that is that Mark Zuckerberg owns a different class of shares that have 7 times the voting power. There is obviously no chance that you, as someone that could go and invest in Facebook today, could gain any access to the board of Facebook. That's just not on the cards, even remotely. Or as, for example, an employee that's earning an equity stock option plan. So someone that is earning a portion of the ownership of Facebook, or at least the right to buy a bit of the ownership of Facebook through work, you also just will never have access to the board. And that common stock, so it has, Mark Zuckerberg's shares have 7 times the voting power, which means that his 11% becomes 77%, or whatever it is when you work it out exactly, which is basically a monopoly on power. And at the same time, Facebook simply has a stated policy that they're never going to issue dividends. Facebook does not issue dividends and never will, according to them at least. And this means that when you own Facebook shares, what precisely are you investing in? Like, where is the value associated with this? I'm going to interchangeably use the word token and equity here because equity really is a subclass of what we would in the crypto space call a token. So if you have this Facebook token, what does it enable you to access? Almost nothing. It's very, very hard to see, other than the association with the brand, what the true fundamental value of that share is. So with profit-sharing communities, we took a completely different approach. And we said, okay, well, what if by owning a share of the community that backs a web application, you had direct access to its profits over time. So for example, if there's a blogging application, kind of like Medium or something, when a user uploads a blog, they pay a very tiny fee. And as well as that fee, that they're paying to the network, they're also paying a tip. And the tip is distributed proportionately to the ownership share in the profit sharing token that backs the community. This is a very simple way of ensuring that the ownership of an application actually gives you, as an investor or as someone that has earned those tokens through directly contributing code and other things to the project, access to the upside in a very different way. We see it as kind of like dividends 2.0, if you like, getting micro dividends every single time someone uses the application. So if that application grows to the size of Medium, suddenly you're getting enormous numbers of tips. And this is just a very solid way of getting value accrual. Yes. So we also see that one of the core problems with the startup model is that the ownership is fundamentally unfair. When you work at even a startup, so for a start, if you work in like enterprise or a major corporation, the likelihood that you're going to get access to ownership of that in any form is basically zero. You'll have to go to the stock market and buy some just like anyone else. Even in a startup, if you're not a founder, you're getting an equity stock option plan. So the ability to buy into the startup's equity earlier is basically the benefit you're getting for your work. But of course, your work is what makes the project valuable in the first place. And this just doesn't seem right to us. It's both morally incorrect and functionally incorrect too, because it means that employees are incentivized more around their fiat take-home pay, so the dollars that they're getting in their account, rather than the value of the thing that they're all working collectively to build. So with profit-sharing communities, we flip the model again, and we say, okay, instead of the profit-sharing community going out and raising large amounts of money necessarily, what if instead we just increased the size of the pie so that we diluted, essentially. We printed more tokens, or stock equivalent at least, when people do things of value to the organization. And so you can think of this like, let's go back to our Medium example. Someone can come along and they can say, okay, this is great, but I think it should have comments. So if I contribute comments, will you guys be okay voting to issue me another 0.1% of the tokens in the system? And then the community gets together and they deliberate and they think about it and they decide and they say yes or no. And then if this person contributes this comment code, then you can issue them some tokens, which gives them essentially remuneration, but remuneration denominated in the value that they have taken part in creating. So they've obviously made the project more than 0.1% more valuable, but so everyone else in the community is incentivized to help them on board because they're raising the value of the organization or the application. And then they get to either hold those tokens and actually access parts of the profit of the application going forward, or they can sell some of it or all of it. And this just fundamentally better aligns the contributors with the things that they're working on. Okay, finally, we also think that you can use these systems, these profit-sharing communities, to perform better governance. So one of the problems you'll sometimes have in a startup is, or even a larger corporation, but by then things tend to be less idealistic to begin with, is governance incentives, right? So occasionally you can have private equity firms or other startups come in and buy up a large quantity of the application, whether that's represented as a company or otherwise, and then strip it and change the, attempt to extract value from it in a way that the people that created it are not very happy with. There wasn't the vision that they were sold by the founder or the early employees or and so on. This is unfair, we think. We think that governance rights should be given to the people that create value. And they should also be aligned with those that are incentivized by the long-term success of the project. So with a profit-sharing community, typically your voting power in the community is dictated by the number of tokens you have, so the amount of the ownership you have, multiplied by the time that you're willing to lock those tokens. So the time that you are willing to have your capital essentially inaccessible to you in other forms, and you are just accruing those tips that and profits that you generate when people use the web application. And this aligns people to say, okay, well, if you have more skin in the game for a longer period of time, then you get to have a bigger say in how the thing is governed. And if you really believe in your project, you can lock up your tokens for a long amount of time. And in doing so, you can really amplify your voice, even if you don't necessarily have too much capital or contribution stake already. So there's I think about 25, this is just a handful of them, profit sharing communities that have been started on Arweave. It's very experimental at this phase. We started doing this about 2.5 months ago. And of course, Nest.land, you can see the logo there, is one of these profit sharing communities. So I'm very excited to hear that you guys will be earning Nest.land tokens over the weekend by contributing to this hackathon, which is amazing because obviously you are providing value to the platform, and in doing so, you'll be rewarded in ownership of that platform. You'll then be able to go to this service called community.xyz and take part in the governance of Nest.land itself. And when people in the future provide profit to Nest.land, you get direct access to that. So you just have a wallet address and you just hold the tokens, you will slowly accrue value. And so this is really exciting, I think. Yes, for what it's worth, as well as this hackathon, we also have what's called the Open Web Fellowship going on at the moment. It's for people interested in building profit-sharing communities, whether in Dino, JavaScript, anything else. I should also mention that you can build all of this stuff in Dino and JavaScript. And so you can start one over the weekend if you like, and associate it with your Dino module, put it inside Nest.land and so on. Yes, we're investing $100,000 in these communities, but less important than $100,000 and more important that there's many people that are very interested in investing in these things, these different kinds of companies, this different structure of organizing labor. I think the last program that we did ended 2 months ago, and already there's been $400,000 of follow-on capital from our 100,000. So it's clear that in the market there's a lot of excitement and interest in this different style of governance and capital management. So sorry if that was a little bit over time. Yeah, okay. But that kind of gives you an overview, hopefully, of what Arweave is about and where profit-sharing communities come from. And then I hope I kind of threaded it together so you can see how this also fits in with Dino and Nest.land.
No worries. Thank you so much, Sam. That was really, yeah, we're fascinated with Arweave, and we're excited to be able to integrate these profit-sharing tokens and build a community within this new form of infrastructure. So thank you. Awesome. All right, Michael, sorry that we've gone a little bit over, but Michael, would you like to talk about SAP and peer-to-peer?
Yes, I would love to do so. That's cool and no problem at all. I, in parallel, made some notes. I hope it's exactly expressing examples for what you said, Sam.
Yeah,
and
perfect. Thank you so much.
Check this out. And the thing is that I'm very happy, that, for example, you, Ryan, do a lot of, let's say, very heavy groundwork. I have to say, code needs to be simple so that I can understand it. I'm rather on the software as a service layer, and I'm very happy if people like you guys, do the, make sure that the infrastructure is reliable and so on. So I think you can also see my screen, everyone. Is that right?
Yes, Michael.
All right, cool. So first of all, I think I best start with a little story to describe you the journey which we went through. So in my department, we regularly offer hackathons as a way of mutual education, for example. I'll come to this picture immediately. I just wanted to go through what we saw. So for example, we wanted to make sure that people have the chance always to do the tasks which they like and where they are good at, or where they want to become very good at, yeah. And so then we said, okay, in the hackathon 2019, I think it was, we explored Gitcoin, which I think is a great thing. Even before we got to know Community XYZ and the corresponding opportunities and so on, we got to know Gitcoin at the time. And Gitcoin is a kind of Fiverr for nerds. I also consider myself as a nerd, so I think it's fine in this round. And so Gitcoin is tightly coupled with github.com. So you can, for example, if there is an issue on github.com and you don't want to solve it by your own, you can fund it, for example, by 0.5 Ether, for example. And if somebody is out there who wants to solve this issue, earning 0.5 Ether, great, this could be done. This is the thing with Gitcoin. And then we thought, okay, what would be really the value for us as a company to promote such things? And here now comes a survey. I did several surveys in different communities, inside SAP, outside SAP, and so on. The one which you see here is pretty representative in terms of the numbers of the responses also and so on. And the question I've asked many people is, how much of your working time do you invest in solving the tasks you like most? Perhaps that's also interesting now for you guys to think about it for a second. How much of your working time do you invest in solving the task which you really like absolutely the most? And on average, this is roughly what came out here. This group of 22 people, roughly, as I said, this was pretty representative. There were some which are closer on average to 100%, and also there were some which are closer to 10%. Yeah, but that's, so to say, what many people say. So, for example, 5 people out of 22 said, okay, about 40% of my working time I invest in solving the tasks which I like most. And that's so, that was, so to say, how can I express this? A motivation to come up with this thing, which we call peer-to-peer enterprise. Always interrupt me, by the way, if there are questions or so. I like being spontaneous. And that's perhaps a bit a nerdy presentation. I also prepared a flashy one, but I thought, no, it's more my style to do it like that. So I would like to go through these points quickly with you. What is the value proposition of the peer-to-peer enterprise? First of all, the peer-to-peer enterprise should make sure that people have the chance to solve the tasks they like and delegate the rest. That's, so to say, the value proposition. We want to make sure of that. Some of the reasons are, we believe that we have with that more happy people, coming to SAP or staying at SAP. By the way, we are also hiring. And we also have the assumption that we get even better results if everyone can focus on the tasks he likes most, perhaps tasks which he or she even loves to do. We think this comes with much better results. And we also think that due to this approach, we get much more fine-grained modules, which is good for the reusability. And the trends towards a microservices architecture at that time already paved the way a bit. Dino now additionally paves this way, from my perspective, in being really able to write very fine-grained modules which can easily be imported and reused. So we think that this is a good thing to do to make sure that we have a kind of global collaboration possibilities where everyone can solve the tasks he or she likes most and delegate the rest. By solving tasks, of course, you earn tokens. Yeah, real money, so to say, and with this real money, you can, for example, delegate the tasks or convert it or whatever you want to do. There, of course, there is also a bridge to what you, Sam, just presented, and it will be very interesting also during this hackathon to figure out what is possible with community XYZ opportunities, for example, and in which context might the peer-to-peer enterprise itself be a good option. A little bit to the inspirations, as I said, Gitcoin.co, I think, was the first which I got to know in the open source scene, which pretty comes very close to offering what peer-to-peer enterprise also offers. The problem here, as I said, is that it is tightly fixed to github.com. And I can also say many big companies like SAP, we have our own GitHub enterprise instances up and running. Some of you might say, what is that? But it is really the case. And we don't even have only one of such a GitHub enterprise instance. We have several GitHub enterprise instances running. And this, of course, is a problem then, because Gitcoin connects only to github.com. We also got in touch with Kevin Owoki, who is the main developer of Gitcoin. And he said, okay, interesting use case. I didn't have this on the radar, and so on. And yeah, Fiverr, of course, I guess many of you know it. But however, of course, peer-to-peer enterprise, open source and open data, values like that, decentralization. These are all things which Fiverr does not do. Gitcoin does. That's really great. As I said, the only downturns of Gitcoin for us, downturn of Gitcoin is that it is tightly coupled with GitHub.com. Yeah, and to community XYZ opportunities, Sam already said many things. It will be very interesting also during the hackathon to explore, okay, what are differences, in which context is the one solution better or the other. I think now, before going further, I show you quickly how it looks like when you take a look at the SAP internal version, which we have up and running. This URL is only accessible from within the firewall, or here from me via VPN. And that's, so to say, the story. You can delegate a task and you can solve a task. That's already the whole point, yeah. And it integrates, as I said, with an SAP internal GitHub Enterprise instance. And this is, however, also something we saw, well, it is much too focused, because some of our secretaries, for example, said, I also want to use something like that, yeah, but my tasks are typically not stored in the GitHub Enterprise instance as an issue. Okay, and then we came up, due to such challenges, to say, well, we could offer during the hackathon a way or a challenge, yeah, where people can develop something like that. We can also offer all the assets which we have here in order to boost this. And we want to create a version which is Dino based when it comes to the backend. I can also quickly show you this, peer-to-peer-enterprise.org. Perhaps I also ping this quickly to the chat that every one of you has seen it. And you might later also watch this video, which is there on the landing page. For the time being, I just quickly rather go to the code. What we use here, this is, as I said, just a skeleton. And we, for example, here have in the server, we use a pretty nice third-party Dino module. It's called Opine. I don't know if I pronounce it correctly. I'm not a native English speaker. Tate, you can also correct me if you like. And we made pretty good experiences with this one. It can be compared from my perspective with what Express is for the Node.js world. Somehow this Opine seems to be for the Dino world. At least there are others, and those others are also promising. I had the flow with this Opine. All right, so that's, so to say, one thing I wanted to share with you. So if some of you guys are interested in supporting this peer-to-peer collaboration, making sure that everyone on Earth can focus on solving the tasks he or she likes and delegating the rest, the contributions here might be interesting, or the contributions to what Community XYZ with the opportunities are doing. Let's see what comes out, in which context, which solution might be the best. I don't want to go too much into this detail, because I want to show you some more things. Also, what we want to do during the hackathon is come up with some continuous deployment solutions based on Dino. Here we prepared something, for example, the Dino module is here called CI/CD. It's also already published on Nest.land. We made it, we got the badge. And here is here are some example workflows. One pretty easily to understand workflow is here the notification via Telegram. For example, if somebody opens a pull request, then we just say Dino run, allow net. Okay, that's necessary for the web access. And then we call this notify via Telegram function. And we have in our secrets the Telegram bot token, the target chat ID, and here the repository about which it is, and here pull request created. Of course, one could do this a little bit more flexible, depending here on more flexible events and so on. But it was, for demo reasons, I think, already a good thing. And if you are interested in contributing to this, Tate fortunately also created a table in the AirMeet dedicated to this CI/CD module. What we also did already, thanks to Ravi in this case, Ravi and How, I think you are the main guys there who contributed to that already today. This is the notification via Slack. This also already works. Many of you, I think, are using Discord. So we are about to also develop the Discord and perhaps even the Microsoft Teams integration. Not sure about Teams yet, but this is, so to say, also a topic which I wanted to present next to peer-to-peer enterprise. And I mean, during this hackathon, it would be cool if we can come up with many fine-grained modules, which we can then more or less just plug and play. I give you another example. I drafted something pretty a long time back. I think I called it, wait a second, where is it? Web3. Also published this Deno module, and there is one guy out there, I think he also is listening. I know many of you only via your GitHub users, sorry for that. Sorembra, that's your GitHub, I think Nico, if I remember correctly. You also already did some great work, how we could connect to the Ethereum blockchain via the Deno runtime environment. So what I did here, it's more or less just a fake, because I have a server up and running or so, just wanted to have this as a kind of proof of concept to show what I want to reach, namely that I can access the Ethereum blockchain data via the Deno runtime environment. But of course, when we can make this in a native way, it would be pretty cool. And if I observed things correctly, user Sorembra are already pretty well underway with this. There are also open issues related to this topic. So therefore, we also created a table in the AirMeet. I hope that those topics are relatively interesting for you. So my overall goal is making sure we have many great fine granular Deno modules, which we can over time more and more just plug and play. So that's really fun from my perspective. And at the same time, make sure that people all over the world have the chance to focus on the tasks they like and delegate the rest. Q&A.
Thank you so much, Michael. That was really interesting. Yeah. So sorry to keep everybody so late, but yeah, this is really cool. If you want to help Michael out, you can reach out to him on Discord. He'd love to collaborate with you, I'm sure. And we're also going to have these AirMeet tables opened all weekend so that you can just hop into this same session and collaborate if that works for you. So yeah, thank you so much for your time to Ryan, Sam, and Michael. And I'll be hopping around the tables after this if you want to chat. And yeah, thank you.
Thanks for hosting, Tate.
Of course.
Absolutely. Especially to you, Tate, because you did most of the organization things. Really.
Thank you, guys. Yeah. Awesome. Yeah. All right, then. Well, I'll see you guys after.
Yeah.
Yep. Let's go with the flow. Bye-bye.